All right. Okay, welcome. Good afternoon. So I'm glad you can join us here. We have about 20 participants in this webinar. And so what we designed for the next few months is we're looking at all of our undergraduate degree programs that are accredited in the College of Engineering. We have 13 of them. And so we wanted to provide information for prospective students or students who are just coming in the fall, as well as high school students. Anybody in the community wants to learn more about chemical engineering. And so my name is Tony Garcia. I'm the Associate Dean for Academics, and I'm also a professor in chemical engineering. And so we have a couple of people as well who are experts in terms of our curriculum. I've only been at NMSU for a little bit less than a year. And previously I had been a professor in chemical engineering and as well as working in industry as a chemical engineer. And so this afternoon we have planned is relatively informal. I'll introduce the key people here who can tell you more about NMSU's chemical engineering program from the department faculty side, as well as from the student recent grad side. We'll show a short video just to give you some overall background as to what careers are like in chemical engineering, why chemical engineering has, how it impacts society. And then we're hoping to turn it over for questions and answers, and we'll see how it goes. We're recording this so that we can share parts of this with people who aren't able to make it to this particular webinar. And so I'll probably be still admitting people one by one here, but you should have a chat box there where you have some information about social media, and then you can post some questions or you can ask questions in a few minutes. And so I just want to first introduce you to some key people. And also first begin by introducing you to Chelsea Lester, and she's our undergraduate program coordinator. So she's there waving, and so Chelsea can be a good person to follow up on. She'll probably provide you some contact email information. And you want to say a few things, Chelsea?
Sure, hi. So my job is mostly I'm the scholarship coordinator for the College of Engineering. So, you know, I'm always looking for how to distribute funds. And so if you're ever in a position where, you know, you're about to be disenrolled, you can't enroll, you're kind of in a desperate situation, I'm here to help you get money and work with the scholarship committee to you know, decide who gets scholarships. So if you have any questions at all about potential scholarships or anything like that, I will leave my email in the chat.
Always an important contact. So then I'll introduce you and let Dr. Roxrose give you some background information. So Dr. David Roxrose, a department head in chemical engineering.
Hi, everyone. As Dr. Garcia indicated, my name is David Roxrose. I've been at NMSU now for 25 years. I've been the department head for 8. I believe we have one of the strongest programs in the region. In fact, I don't believe it, I know it. I fielded 2 emails today from employers already planning on coming back, and in the emails to them, they talked about the skill set of the people that they've hired from NMSU as being strong and the reason they keep coming back for more. These include the National Nuclear Security Administration. We've placed a number of people in their program through the graduate fellowship program, as well as Glanbia Nutritionals, a food processing company that's growing quite large and has been taking a lot of our graduates over the course of the last few years. They consider our program top 3 in the world of places to recruit from within their company. I also see some alumni on the phone that can provide some testimonials. I see Areli Torres. Areli, if you could wave. Areli hold the title Mother of Aicg. Under her presidency of the American Institute of Chemical Engineers, the student organization really launched. It has been one of the best student chapters in the country for some 10, 12 years running now. They've been recognized as outstanding chapter in the country. I believe it's 6 of the last 11 years they've earned that title. See Daniel White. Daniel, give him a wave. Finishing his PhD out in California in grad school right now. I also see Shane White. Acknowledge yourself, Shane. There you go. Shane's working up in Denver. Shane had reservations about doing the degree. And as I'm sure he'll testify, one of the best things he did is stick it out. What he found in the program is that the faculty believe in you, regardless of whether you believe in yourself, they will believe in you, and they will do what it takes to help you get through the program. So with that, I'll turn it over back to Tony to continue the program. And when the time is appropriate, I'll be happy to answer any questions you might have. I introduced those 3 also because there may be specific questions that go to them about their experience and what they've done since completing their degree. Tony?
Thank you, David. And also want to turn it over to Sarah Fox. She's on the phone there, so she can introduce herself and say a few words.
Hi, everyone. So sorry I can't be through Zoom. I'm at my grandparents' house and internet is not a thing. But I just recently graduated and I'm going to be working at Raytheon at White Sands with the missile defense area for quality assurance. And I've been really involved through college at NMSU through Greek life and Aicg and Aicg. So if you think chemi is difficult, you really can do anything with the degree while in college as well. Back to you.
All right, thank you. Yeah, so like I said, I've been at NMSU almost a year, but I've actually been a chemical engineer for 40 years. And so, so I think between myself and Dr. Roxrose, we were looking with Chelsea's help at different videos to give you kind of an overview as to what chemical engineering is about. And so I'm going to share the screen. It's a short video. It's about 8 minutes. Hopefully I'll get the volume just right. You may need to adjust your volume in case it starts blasting. But we like it because it really does. This is a piece of a YouTube video that encapsulates, I think, a lot about what chemical engineering is about today. It's a relatively recent video. So if you bear with me, I'll share the screen. All right, so that was pretty quick, but it was a very comprehensive overview. And I particularly liked it because, like I said, I've been a chemical engineer for 40 of those 50 years that were kind of explained there. And so I think the key thing for us today is to reflect also on the fact that everything that you saw in that video and the broad categories of different things chemical engineers could do, you can do by majoring in our chemical engineering. We have courses that encompass the bio areas, the energy areas, the process control areas, and the biotechnology, bioprocessing, biomedical areas, which is a little bit closer to my area of expertise. But also we have a lot of interest in areas that relate to the chemical process industry within our degree program. And so what I'd like to do is also turn it back over to Dr. David Roxrose. Maybe he can engage a little bit in our graduates, since I'm new, so I don't know much about all of the different things that our graduates have done. And maybe he can also ask them to explain a little bit more about the kinds of things they're doing in their careers. David.
Well, as diverse as the video showed chemical engineering to be, it really is only the tip of the iceberg. Those areas seem to be quite wide, but the potential things you can do with this degree aren't limited by that video by any means. In fact, there's so much more. I personally have worked in food processing. I've worked in pharmaceuticals. I've worked in agricultural chemicals. I've worked in nuclear energy and nuclear materials before coming to NMSU. And I don't think any of those are mentioned except for energy as a general field. I know Aurelie, Shane, and Daniel are probably all doing something quite different from anything you heard in that video also. If they're willing to talk, I'd love to hear from Aurelie to talk a little bit about her career. I'll stage it a little bit. Aurelie left NMSU and went to Kansas, where she did a PhD. And I know at the conclusion of her PhD, she joined Archer Daniels Midland and worked on a process that involves soybean oil. And she's now with Lyondell in Houston, working on, I believe it was polyethylene or polypropylene?
Almost, propylene oxide.
Okay, I'm close. And so Aurelie, if you can give a little background on what you've done as a chemical engineer, that would be great.
Sure, thank you. So I left NMSU in 2008, then went to grad school in KU, University of Kansas. I did my PhD on converting biomass molecules into chemicals. So I worked on glycerol hydrogenation to propylene glycol. Propylene glycol you use in shampoo, in paint, in cough syrup, all kinds of things. And so I liked going with that sustainability or renewable chemicals. Then I was able to do a postdoc with Archer Daniels Midland, where we worked with doing oxidation or ozonolysis of soybean oil to produce these chemicals that you could use in fragrances. Then I got the opportunity to work with Archer Daniels Midland, which is mostly an ag processing company. And we were working on a pilot plant where we were taking high fructose corn syrup and converting it into a monomer to produce better plastic bottles that would have higher shelf life, less weight. Then I moved on to Lyondell, where I also, it's more of a traditional role that you would think for a chemical engineer in the chemical industry, working on making better ways of producing propylene oxide, and how can we make those processes that are so old, over 50 years old, more sustainable.
Thank you, Aurelie.
And so going from small scale in the lab to big scale now.
And so the point behind having Aurelie and Daniel talk, I'll have Daniel talk in a moment, is to demonstrate that your NMSU chemical engineering education prepares you for graduate studies anywhere in the world. Aurelie went to Kansas, Daniel's out in California. We've had students go to MIT, Northwestern, Michigan. I can list all day. We have a national fellow, a National Science Foundation fellow right now at the University of Minnesota. So the education you get in this program is second to none. Daniel, introduce yourself. Tell us what you're doing in California. I really have very little clue of what the research you're doing. You haven't been gone that long. It's hard to catch up for someone who just left.
That's true. That's true. Yep, I'm out in California, University of California, Riverside. I had originally graduated in 2017, came out here to study water purification. So I was looking at redox chemistry of water treatment, and I was looking at how smart particles behave in water, like maybe bacteria or virus. How do we treat those out of the water? But one day my advisor emails me and says there's this National Science Foundation fellowship available if you're willing to do anything with insects. So what we did was we took those fundamental skills that I learned in chemical engineering and found a way to apply it to insects. So now for the past year and a half, I've actually been studying how crop disease is spread by insects. I've been simulating fluid dynamics inside of the insect to see how that makes bacteria attach or detach. So it's really been a lot of like mass transfer and kinetics, and it's all kind of related, same fundamental skills, but just like Dr. Roxrose said, you can apply it to a lot of different things.
I'm glad I have Daniel poke his nose in there, because that is way out in left field. That 25 years I've been doing this, and I haven't heard that description yet as a post-graduation career.
Yeah, that's a new one for me too.
Shane, are you there? You turned off your video. We'll see if he comes back. I also see Emily Fensky, who's now a junior in our program. Emily spent some time in Ireland, I believe it was, on an exchange program. Emily's heading in the direction of brewing and distilling. So another area that wasn't covered by the video, you can brew beer and distill spirits as a chemical engineer, and NMS Brew, a program in chemical engineering at NMSU, is now the national champion in beer brewing through the American Institute of Chemical Engineers. I see Emily turned the camera on. Emily, can you talk a little bit about where you're heading with your career? Because it's not fluid dynamics and insects, and it's not bioenergy from bioproducts. It's something completely different.
Yeah, so like Dr. Roxrose said, I'm doing the brewery engineering minor. I'm not sure exactly what I want to do in the brewing industry yet, but I know there's tons and tons and tons of options. I'm hoping next summer or this next summer to get an internship at a large brewery, because I've had the opportunity to work at some smaller breweries, but I would love to see, you know, that the whole brewing process at scale. So yeah, so we'll see where it takes me.
Thanks, Emily. I'll also point out that Vlad has posted a video about the NMS Brew National Championship that was recently posted by the Vice President of Research. So as you have the opportunity, you may watch that video. Dr. Brewer, and no, I didn't have her change her name to be the professor of the brewing program. Dr. Brewer has really taken that program to levels that I could not have done. Her relationship with the ag department, food science, Stephen Taylor, who also teaches in the program, she has really developed a first-class program there, and I look forward to what she might do next. So I got a note that Shane had to go take a call and he's unavailable. So at this point, do we want to open it up for questions?
Yeah, I guess I'll just add a little bit of 2 cents and then we'll open it up. It won't take very long. But just to round it out, we also have in chemical engineering a group of people doing research in biomedical devices. And so I just heard, I couldn't resist because I heard fluid mechanics here going on with our grads and in research. So when you think about what we do in chemical engineering, a lot of it is applying principles of math and physics, but we apply it in lots of different ways. And so what I'm doing right now is developing a rapid system to take saliva and analyze for antibodies, specifically for this particular pandemic that we're in right now. And so the way that works is that you have to think of all of the things you learn in terms of fluid properties and decide what's the problem. And the big problem in medical diagnostics, as we all know, is access, availability, and accuracy. And so 2 of those 3 things involve engineering principles. The third one has a lot to do with biology. And so to solve this problem, what I'm doing basically is applying a principle that I learned at Exxon, which is in petroleum recovery. How does oil and water, if you were to try to do tertiary recovery, what people tried to do in the early days is inject water to push the oil out. They found out that they couldn't do it in the range that they wanted. And that principle is called viscous fingering. So that field developed, and the understanding that developed over the last few decades. I'm applying that problem in chemical engineering, petroleum engineering, and using it to actually make this an advantageous way of measuring saliva. And so we're able to get a very simple system, have saliva going through these porous material, and then have the biologists that I'm working with develop the nanoparticles that will actually detect the disease. So again, the broad range of chemical engineering you heard about, the way that we solve problems, the way that our curriculum here specifically is very rigorous. because it talks about biology, it talks about physics, it talks about chemistry, but then it also goes through all of the engineering methods. And so I think that's the real power of what you learn in chemical engineering. And you can learn it, like I said, in the field, in the classroom, as well as through these competitions, through the brewing competition, as well as through some other potential opportunities we're going to make available this coming year for entrepreneurship as well. So yeah, let's open it up to questions, because I think we're almost at the halfway point, and I think that's the more interesting part, is when we actually get to hear questions and try to answer questions. All right, so we got one question here. I can read. How would computer sciences work alongside chemical engineering? Do you want to tackle that one, Dr. Roxrose?
I can take a first stab at it. Chemical engineers solve some pretty complex mathematical expressions to predict and simulate nature. Solving these expressions can be quite trying. We use numerical techniques, and numerical techniques necessarily require computational strategies. And so in some ways, chemical engineers are a miniature computer scientist, because the amount of coding and software, simulation software that chemical engineers have to use just to get their undergraduate degree is relatively significant. In fact, 2 years ago, chemical engineering started offering a minor in computational engineering. So in addition to the computational based courses they take in the curriculum to begin with a few additional ones, you can now get recognition that you have some proficiency in computations. Is Lauren Evans on somewhere? Doesn't look like it. Lauren just graduated in May, and she is now going to graduate school for computer science. She has a job offer waiting on her, but while she waits to get security clearances, she figured she'd knock out a master's degree in computer science because she's so well poised for that particular degree. I would imagine that based on the description Daniel provided out at UC Riverside, he's doing some computational work himself. Is that true, Daniel?
Yes, that's true. Lots and lots of MATLAB. So it's a good thing that we had plenty of exposure to that.
And so have you had a need to reach out to a computer scientist yet, or are you handling all that on your own?
That's all in-house. Yeah, just been tinkering it, figure it all out. And I figure once you know the language, it makes it a lot easier to get the rest.
So at some levels, chemical engineers are trained and capable of performing the computational work themselves. One of the software products that you'll work with while you're a student in the program is called Aspen Plus. And Aspen stands for Advanced Simulator for Process Engineering. It's essentially the software that all the big chemical companies use to simulate a process before they invest tens or hundreds of millions of dollars in a capital project. At that level, having a computer scientist handy is very convenient because the complexity of that program is so tremendously large. Just the simple act of installing it and setting up his license here at NMSU requires that we reach out to help from ICT.
Yeah, and I'll reiterate that minors are also another important component. So majoring in chemical engineering, because of the ability to take a lot of the courses that involve different areas of math and sciences and even industrial engineering. So adding computer science as technical electives with just a few additional tweaks to your plan of study, you can minor in it or minor in a related engineering field like electrical, computer engineering, or industrial engineering that uses a lot of tools. The tools that I like to use now are different from when I was a process engineer. Right now, I work with a company and we do a lot of machine learning. Machine learning is a hot area for diagnostics because You can look at multiple variables and create pictures and maps of how things can be distinguished between a diagnosis of a positive versus a diagnosis of a negative. The other area that I'm really keen on is agent-based models, which is a little different type than MATLAB, where that's a deterministic model. And these agent-based models are kind of cool because you can simulate using rules complex behavior. And this is important for understanding complexity, especially in biology, but it's also important to understand and simulate real world events. So both of those areas are are relatively new in terms of their applications. And certainly those, you can take courses in that. So another question here that came was, would it be ideal to minor in physics? So I guess maybe we can ask either current students or graduates what kind of things they think about that. I don't know.
I tend to ask students when they're talking about a minor, a double minor, or double major, why? What is it you want to get out of taking those two lines of study? Particularly with respect to double majors, that adds a lot of additional coursework. It typically extends your stay at NMSU, and with average starting salary at $80,000 a year, if it takes you an extra year and a half or 2 years to get that second degree, you've just thrown $150,000 out the window. With respect to minors, my strategy has been if it's convenient to get one, then you should get one. If you have a strategy for using it, then you should get one. If not, then you want to get the degree as quickly as you can, because you see with Aurelie and Daniel and Shane and Emily, there are great things awaiting on the other side of graduation.
So any other questions? You can ask the questions too through Zoom there. You can unmute yourself.
Aurelie, do you have something to add to the computational discussion?
Yeah, for the computer science. So in my experience, I've had the opportunity to develop a couple of processes of different pilot plants that I've never done before. And so what we do as chemical engineers is we design the process. We say, I want these valves to work this way, and we write what we call a control narrative. So I want this flow meter to do this at this rate and to have all of these functions. And then we give that to our computational or our computer science department or IT department on site, and they program the actual control system. And so we put that in simple terms, not coding itself. I just say, I want this instrument to have this function and all of these interlocks or safety logic that we want to incorporate. And then the programmers actually go and do the programming in the control system. So that's one of the interactions that I've had with computer science at work.
Thank you, Aurelie. I saw Madison Solis was trying to talk, but she was on mute. Madison, did you have a question or a comment?
Oh, sorry. I was trying to talk to my family, but I think my dad's off the phone now. So if you want him to say some words, he can.
Madison is the daughter of Vern, who graduated from NMSU Chemical Engineering. And let I get this right, 1998?
Yes, Dr. Roxrose.
So we've got, how many years is that?
22 years.
22 years. Oh my gosh. So Vern is an example of why you don't need to go to graduate school to use this degree. He went straight on to ExxonMobil and has been having a heck of a career. He's given back to the department on numerous occasions, coming back and serving on advisory panels and actually chairing the advisory panel at one point. So Vern, tell us a little bit about your career at Exxon.
Yeah, so started on back in the day with Exxon and originally hired on with what they call the lubricants group. So simple matter, guys, is the motor oil that goes into your car. That was the closest thing I could interpret of fluid dynamics into a car. From there, at Exxon, they actually had me go all over the country. I think I've moved around the country 8 times. And I think the last time, I think I was talking to my daughter, I think I've had 19 jobs in the company in 20 years, or 22 years, excuse me. And they've ranged from anything from doing technical sales, which was like fluid dynamics, working with customers on heat transfers and all that, to managing supply chains, to actually what I call carrying the football for our vice president in marketing. So if you've seen NASCAR, where Mobile One, the branding, the logos, all that, trying to tell the vice president kind of the story on what to do globally. And then actually went into what we call retail. And that's actually where now I've been for about 6 years. And if you go into the world's largest retailer, Walmart, I actually handle the entire supply chain to Walmart for Mobile One in the automotive department. So I actually work with groups of data scientists, sales team, marketers, and basically learning how consumers buy our product and trying to figure out how to replenish as fast as possible. And it's an interesting concept because it still goes back to Dr. Roxrose and many of the other professors, what goes in must come out. And that's exactly what we're trying to figure out. What goes into Walmart, when is it going to come out? How is it going to come out? And how do we basically try to outsmart the consumer and making sure that it's there and we don't disappoint the consumer. So very, very interesting approach to it. But I can tell you that it's been exciting because there's been many times where I've been at NASCAR tracks as an engineer talking to the NASCAR teams, but then I've also been an engineer having to deal with hurricanes and trying to figure out how do we get pumps protected before hurricane floods happen and how do we get them started up immediately. So a whole broad variety, but I can tell you that being a chemical engineer, you know, I look at it that it's a versatile job. It's a versatile engineering career that I would not have imagined what I'm doing today. That's what I was going to be doing 22 years from now, or 22 years ago. And it's pretty exciting because I'm working with mechanicals, industrial, data scientists, and it just continues to demonstrate to a lot of them going that this job or this career and the opportunities I got with New Mexico State were broader than many other opportunities they had.
Thanks, Vern. Hope to see you back here eventually.
Absolutely. Obviously, you can see I got my Zia symbol, and
yeah,
that's actually how everybody knows.
Wardrobes. We did not coordinate wardrobes.
No.
I'm sure you did. That's great. That points out a couple of trends that I think are really important too, from what I heard, that I do believe it's something to think about, and what we're planning on having for you in the fall as well, which is the whole idea of the business. How do engineers interact in the business world? This is through really understanding the customer, as we hear, and understanding use your engineering skills. So what we do is we focus on knowledge, but we also focus on the engineering method and the engineering skills. So how do analytically you look at that? We also look at entrepreneurship. How do you create something from nothing? And to me, engineering is always exciting because it's the art of creation. We're not applied physicists. We're not applied mathematicians. To be an engineer, as Dr. Roxrose has taught me in my year here, or my almost a year here at NMSU, it goes beyond the textbook. And that's what we believe in. And I think you've heard that already. So we're hoping to have more opportunities for you to work with Crimson Entrepreneurial Program, through Arrowhead Center, just through looking at what our students are doing, competing in different things, looking to raise startup funds to launch their projects through Aicg Innovation Space. So that's an important area. And then the one I'm very passionate about, because again, we live in the information age. I think chemical engineering can make an important contribution to really this area of big data. Right now, we're working in areas that require us to understand the world, the global markets, also consumer trends, and to try to figure out when we have disruptions around the world, which unfortunately may come more and more in terms of disruptions in economies and disruptions in our global network. How do we prepare for that from an engineering perspective? So big data, information science, and making sense of all of that are, again, skills that engineers have. You don't have to be a computer science. It's great to know it, as you heard from one of our grads here. But you have to understand that you also can work with them, and you don't need to know all the details. But having that analytical ability, I think, is really important. So to give you another example there about big data, is that for a simple example is that if you want to do research about how students are learning now, so we're all on Zoom because most of us were forced to use Zoom when we had this transition to digital learning. So right now there's a huge experiment out there in the social media and in the internet where we're actually, if you know the tools of big data, you can use tools in Google, you can use tools in Reddit. Those of you who may use social media looking at universities, each university has a subreddit, R-E-D-D-I-T, which is the front page of the internet, is how they call themselves. So you can go back in time and see the evolution of these things and use data systems to actually unravel how things occurred in terms of learning. So those of us, I also have an interest in education, digital education. This is a new way of looking at, rather than doing an experiment in a classroom where you start creating a new digital learning tool and then you see how students adapt, you can actually use big data and use some tools, data mining, data scraping, and things of that nature, qualitative analysis, and you can reconstruct with an engineering perspective and make sense of all of this information using different kinds of tools and different software. So again, just to emphasize what I heard so far from the graduates, that chemical engineering, we focus on a specific subset, but then there are all these skills that are also developing and develop once you're in the workforce. So any more questions? Anything at all? Anything, small questions, big questions, medium questions?
I have a question. So how many of your undergraduates would you say that get a job right out of school? Like what %?
You repeat the question, I didn't hear it.
Oh, my bad. I asked what % of your undergraduates that graduate, what would you say like the % of them that have a job waiting after they graduate is?
Oh, that's close to 100%. They're either employed or going off to graduate school. The handful that don't have a job waiting typically find their way by the end of the first summer. There's a big push to fill positions early in the spring semester, and then late in the semester and early in the summer, employers have that some of the commitments that were made aren't kept, and so they come back looking to fill positions that were originally filled, but the person eventually turned them down. And so I typically have more jobs late in the summer than I have students looking for jobs.
And I think it's going to be even more important next year because there's going to be a big push for improving our manufacturing capabilities in the US. And there's also going to be a big push in terms of technological innovation as we look at things that we think should be improved all throughout our society. So I think this is, it's a good area, and energy is always going to be very important. And supply chains, as we heard before, are going to be even more important. So while we have this big dip in the economy, by the fall, you're going to see a lot of economic activity as people invest in the next scale of innovation.
Yeah,
So,
the degree will change your life. If you decide to go to industry and get a job, you'll find one. If you want to go to graduate school and you maintain a decent GPA, 3.2 or above, being a domestic student, you'll find an opportunity there also. So the degree will change your life. I can guarantee you that.
So we have some questions that we can direct to our graduates. I think, I don't know, if Sarah's still on there. Okay, so the first question is, what are some things that you can advise students to share for incoming first-year students? Activities that can help you as a student, things of that nature. So maybe we have one of our current students or recent grads can answer that.
I think in chemical engineering, the first thing you want to do that's not curriculum related is pretty obvious and simple. And I see Aurelie smiling. Aurelie, you want to tell them what that is?
Join AICHE.
Period. American Institute of Chemical Engineers student chapter in the department. What I've seen over the years is the students who get heavily engaged in that are the first ones to get jobs. Employers aren't just looking for a 4.0 GPA, they're looking for a skill set beyond academics. They're looking for your ability to lead. They're looking for your ability to talk. They're looking for your ability to be a member of a team. And all those soft skills are developed through your participation in AICHE. I see Daniel shaking his head, yes. That organization has really been second to none on this campus for over 10 years now.
Yeah, that's great. I would advise the same thing. So the next question is getting a doctorate in chemical engineering worth it?
Well, I have one, so I can start.
I can tell you how much I make. That's how I usually start this question, David. Do you want to know how much I make now?
It really depends what you want to do. I don't like keeping a schedule. I don't like 8 to 5. I don't like having a boss. Having the PhD, starting my own business, rising to the level of department head is really freed up a lot of schedule for me. I can come and go as I please, as long as I get the job done. I can pick and choose the things I want to work on. There's a lot of advantages to having a PhD. On the other hand, it does close some doors for me. I will never be a process engineer again. I will never be responsible for a process and run the process and get to know that process very intimately. I won't say I can't. I probably could. It would require a pay cut and a change in lifestyle. Having a PhD has a lot of advantages. Aurelie, I'm sure you've encountered some of those advantages also. Your foray into R&D, industrial R&D, has permitted you to build facilities costing millions and tens of millions of dollars just for the name of research. You might want to speak about that for a moment.
Yeah, and it doesn't mean that you won't run a process. It's sort of like venturing into new territory. It's like nobody's done this before. It's not in a book. You do small scale experiments to inform you in some way, and then you do as much risk mitigation as you can, and then you go. So again, I think that Dr. Roxrose is right. It just depends on what you want to do. I originally wanted to teach, and so I know that to be a professor in a major university, you have to have a PhD, and then I changed my mind. And I've had a lot of fun because it's not a well-established process like you would have in a plant that you know where you want it to run, and as long as it runs there, you don't touch it. Just leave it alone. Research is very different. You want to know what the limits are. You want to know how can you make it better, still within the business constraints, right? Because you don't just spend money because you want to spend money. You have to have a business reason for it. So I find it's it's very versatile. It lets you do a lot of things, but again, it closes you off from other things too.
Yeah, and I'll put my 2 cents in. I came to the United States as an immigrant, 3 years old. Family had, my mom and dad didn't have more than 8th grade education. And so the beauty of the United States is, you know, we have the best university system in the world, bar none. And the pinnacle of American universities in terms of education is the PhD, because the PhD is very unique here. We're very individualistic in the United States. And so as a result, you already heard, people come at this differently. They have different careers. And in the PhD, I was always fascinated by new ideas and new things. And I make pretty good money. I make so much money that I have to pay Uncle Sam quite a bit of money this year. But more importantly, it's the impact. So impacting students, funds for students, creating projects. I've had the pleasure of supporting over 30 years, 7,000 students at the undergraduate level through projects that I've raised money for. That's probably the most important thing I've ever done in my career. And now I have a new $2.5 million grant to help support engineering students at NMSU too for the next 5 years to do different things like entrepreneurship and stuff like that. And then as Aurelie just said, I have a device that is being developed commercially. Companies have spent $150 million developing this medical device. Can't disclose much about it. An inventor, I already had a royalty stream. I'm hoping to have a lot more of that money, royalty stream in the near future. Most of what I'll do is just plow it back into university systems because that's really, I'm passionate about that. And as Dr. Roxrose said, you know, this is really not working for a living. This is more like, you know, every day is a new intellectual challenge. And I think that's what you can do with a career as a PhD. So next question, how do we join Aicg as an incoming freshman?
Show up at the first meeting. Keep an eye on the calendar, show up at the first meeting. There's a calendar on the chemical engineering website where the meetings are posted. Aicg maintains a Facebook group where they post meeting information, and really all you have to do is show up. I might also comment that the undergraduate degree is going to take you a minimum of 3 years, and if you're like me, up to 6 years to complete. During that time, you will be immersed in the discipline. Not only will you be immersed in the fundamental topics and the applied topics in your courses and the textbooks, you'll likely get involved in internships or research experiences for undergraduates on other universities. Almost every chemical engineering student gets involved in something of that nature. I know Emily spent a semester in Ireland studying at a brewing and distilling university. About half or a third of the students get internships in the industry with companies, energy companies, chemical companies. Another great number of them go off and do research experiences for undergraduates at other universities. And in this immersion, you will start to see all of the different options that are available to you. And so you may think you want to come here and study chemical engineering to go to medical school. And I've seen students do that, and they end up fracking in West Texas because they were so taken aback by some of those other opportunities that they changed their minds. So while it's great to have some direction on where you want to go, recognize you're going to see things that you didn't even have a clue were the domain of the chemical engineer that may steer you in a different direction. Aurelie wants to be a professor. I never wanted to be one. This is just sort of the direction the wind blew me. And I've been here for 25 years, and I'm already seeing my next direction. I've got another career that's taken a good bit of my time right now. And I suspect that within a few years, I'll be going off in that direction. So this degree will let you navigate life in ways that you can't imagine.
Yeah, now we have another question. What are some of the medical corporations students have found jobs with?
Well, we have Jabil right here in Albuquerque, and we have students up there right now working both as full-time engineers and as interns. They were a subsidiary of Johnson & Johnson. in terms of medical, if we include pharmaceuticals in there, I worked in the area of pharmaceuticals with Ethel Corporation, developed a patented process for the manufacture of ibuprofen. Again, I'm not even hitting the tip of the iceberg. Dr. Garcia can tell you more based on his research as a professor.
Yeah, and certainly the medical corporations, the medical device corporations, Jabil, that makes implants, that's an important area for chemical engineers and people that are interested in medical applications, especially from the aspect of materials and how the body interacts with implantable materials. And then our graduates can go into Amgen, Genentech in the biopharmaceutical area. The biopharmaceutical area continues to be a growing area, especially with more and more interest in terms of vaccinations and treatments for a variety of different new classes of therapeutics that are coming to the market. So in the pharma area, pharmaceuticals, you would go out to the East Coast or the West Coast, basically, in order to work in those areas. In the small startup companies, I think you can even get involved in diagnostic companies, and so we have Tricor is a company here as well in New Mexico that does a lot of testing, and so I don't know if we have graduates there, but I think that's going to be an expanded area. And I just mentioned chemical engineers are perfectly suited for that. So it's more of a question of our students just looking at that as a job market. And I think Tara is interested in the medical area as well, but I'm not sure whether this is a recent grad, Tara Schulman, whether she's going to go into that field right away. So the next question is, how do we apply for internships, co-ops in the future? What are the requirements?
Well, there are two big employment events on campus, one in the fall, one in the spring. The fall one is called Career Expo. The spring one is called Career Connections. And at those events, hundreds of employers come to NMSU. They set up booths. They perform screening processes where they collect resumes and they make decisions on interviews. Thanks to Aicg, students go to those events very well prepared in terms of having the resume cleaned up, in terms of dressing appropriately, in terms of knowing how to introduce themselves with confidence to a potential recruiter. You essentially go to those events and you put yourself out there. You bring your resumes, you hit all of the recruiters for chemical engineers, and you hit those who aren't there recruiting for chemical engineers but should be. They just don't know that they want chemical engineers yet. And I say that because I've seen it happen. I've seen recruiters say, we're not here for chemical engineers, and then the next thing you know, they're interviewing chemical engineers. So it's a process that the university mediates and Aicg prepares you for. And it's a matter of being there. You have to show up, you have to dress properly, and you have to have confidence in yourself. And that's what the program will do. It will give you that confidence to go in there and sell yourself.
And we also have a learning communities, Eloy Torres learning communities on the 3rd floor of the engineering center. And so we invite companies to give presentations. And so we'll be up and running with that more and more. With Zoom, actually, it's even more interesting because a lot of times we have trouble scheduling these folks, but now we can have a combination of when they're on campus and also when they're available, we can hook them up through Zoom. So we'll be able to give everybody exposure to these companies, and you can ask questions. That's the best way to line up an internship. So I think last question. Did I get all the questions? I think I did. Or you can ask a question just by unmuting yourself. Okay.
Well, what you'll find is the chemical engineering faculty process their email in real time. So if you've got questions and you're too shy to ask them, or you think of a question at the conclusion of this, feel free to write any of the chemical engineering faculty, and I assure you, you will get a response in a very short turnaround.
And yeah, through your invitation, I'm sure you also got my contact info, but I've left I'll leave my email to everyone, I guess. I clicked the wrong thing. Everyone in the meeting. Okay, so here's my email address as well. So you can also contact me, and then I'll route it to the right person to answer your question.
I'm also point out that the chemical engineering website is always up to date. I know the guy who maintains it, and he keeps it very well up to date. So if you spend some time on the website and can't find an answer to your question, send me an email and I'll send you to the link to where your answer is at. And if your answer is not on the website, you won't know it because I'll put it up there before I send you the link.
And then we also have here a video of the College of Engineering resources. So if you save your chat area, you can get all these links. And Chelsea also provided a link to the Aicg student chapter.
I'd like to thank our alumni and students for joining and helping to answer questions. It's great seeing you all again. That one thing I really like is watching post-graduation, how these graduates of this program just blossom. Their careers are just mind-blowing, some of the things that they're accomplishing.
Yeah, that's my real email address. So garcia81@nmsu.edu. Sorry, I just typed too quickly. But it's a pleasure getting to meet you and actually talk to the alums, which are great as well to hear from. So I'm going to, I guess, end this at this point, and then we'll provide the recording as well if you want to go back to anything in here. And so Vlad will be coordinating the videos and putting them up on our social media websites. So have a good night. Thanks for participating. Take care.